Hello, welcome everybody. Here is your video lesson on an introduction to Chapter 2. Chapter 2 is going to be a short chapter. We're only going to do a couple sections, but you will need to understand the use of these following properties I'm going to go through. You may or may not have had experience with them. Don't write anything down on this slide, as you'll be getting this note sheet in class the next time I see you. But I just want to cover a few of these things briefly, so when I start doing a problem, you understand where I'm getting these things from. First of all, let's talk about the words. Addition property of equality. Equality means equal sign. So when you have an equal sign like this, and you're going to be adding something to both sides of the equal sign, that has a special name. It's called the addition property of equality. Now here's a sample using all letters, but you're most likely seen this in this form. X plus 2. Actually, you know what? I'm going to do x minus 2 instead of x plus 2. This will illustrate it a little bit better. So x minus 2 equals 7. Well, how do we solve this problem? We add 2 to both sides, and we end up getting x equals 7 plus 2 is 9. So that's how you do a math problem like that. But the most important part of this is, as we, using my laser pointer here, as we added 2 to both sides, how can we do that and why can we do that? Well, we can do that because adding 2 to both sides of an equal sign still holds the equal sign true, but that special name is called the addition property of equality. You're going to need to be able to understand that in all of these for all the proofs that we're about to embark on. So for the next one, the subtraction property of equality, all I have to do is change this to an addition sign, and when I subtract from both sides, that's the subtraction property of equality. An example, the multiplication property of equality would be like 2x equals 4. Now, of course, you can divide by 2 on both sides. That would be the division property of equality. But another choice would be to multiply both sides by half, which is still solving this problem for x. So x would then be half of 4, which is 2. That's called the multiplication property of equality because the way I showed my work here, I'm multiplying. Distributive property, you should be very familiar with, 2 parentheses x plus 1. If you ever distribute this in and get 2x plus 2, that's called the distributive property. There's a couple more. Reflexive property, sometimes you're going to have like a equals 2, but it's going to be easier if you have the 2 on the left instead of the right, so you might flip this around the equal sign and go 2 equals a. We'll cover that when we get to it. That's called reflexive property. Substitution, we're going to identify like this. If we ever have like x minus 2 equals 7, like on the last slide, and we add 2, that's called the addition property. But then we're going to be substituting in 7 plus 2 and doing some math. Anytime you do some math and you get 9, that step could be called the substitution property of equality. There are more details there, and we'll talk about it. When I mentioned this switching around here, I actually made a little mistake. That's called the symmetric property. Reflexive property is just such an easy one when you just have the same thing equals the same thing. Transitive property, if you have a equals 2 and 2 equals b, if they're both equal to 2, then you could say a is also equal to b. That's kind of like taking this middle guy and cutting it out like that. That's called the transitive property. That's going to be very important for a lot of proofs we do, so we'll cover that more in detail. So now you've got a rundown. You need your title, so 2-6 algebraic proof. And then this will be warm-up number 1, and I'm going to do example number 1. So here's warm-up number 1. So what I'm going to do is I'm going to be given this math problem right here. So if you need to pause the video because I'm going too fast, feel free to do that. But you got 2 parentheses 5 minus 3a minus 4 parentheses a plus 7 equals 92. the answer in this case will be given to you. So I know I'm going to get down to a equals 11, negative 11. So how would you normally solve this problem? The normal thing you would do is you do what we call distributive property. So you're going to put this 2 in here. So I'm going to get 10. You're going to be doing some math. And then you have a minus sign. 2 times 3 is 6, so 6a. Now this, I like to think of this minus as plus a negative 4. And then that's kind of weird. That's a negative 4. And then the negative 4 gets distributed into both of these. So negative 4 times a is negative 4a or minus 4a. And negative 4 times 7 is negative 28. That equals 92. Now what did I do here? I did the distributive property. So now I'm going to write that. I'll abbreviate it because my slide's kind of small here. So distributive property. Okay. The next thing I'm going to need to do is I'm going to need to combine some things together. Now I'm not going to be doing it to both sides of the equal sign. So I'm not going to be like, for example, when I take this 10 and this negative 28 and combine them to get negative 18. That's not what you would think is the addition or subtraction property because I'm not doing it to both sides of the equal sign. That's the difference. So I'm just going to combine these two, and I'm also going to combine these two right here. Negative 6 and negative 4 is negative 10a. Anytime you work on some math, we're going to call that the substitution property. Anytime you subtract, but not to both sides, or you add, but not to both sides, or you divide, but not to both sides, anytime you do some math, it's called the substitution property. After you do plenty of these, it'll become apparent. Now I'm going to get a alone, so I'm going to add 18 to both sides. Cancel these two. I get negative 10a equals 10, carry the 1, 9, 10, 11, 110. So now what did I do? I added 18 to both sides, so that's the addition property of equality. Instead of writing it all out, I'm running out of room here. I'll put an equal sign. You can do that too on your notes and your problems. And then I'm going to divide both sides by negative 10. Cancel. So a equals 110 divided by negative 10 is negative 11. That's what I wanted to get to. I wanted to get to this proof statement. So when I get to the proof statement, I'm done. I'm complete. But I need to have justified each step. When I did some math here to here, I added. So when I do regular adding to both sides, it's addition property. But here I did the actual adding, so we call this substitution. Substitution property of equality. Then I divided by both sides by negative 10, so we call this the division. I'll abbreviate property of equality. And then my last step is I actually did the division, and that's called substitution. For now, we're going to always put substitution property on every other step. Now this may seem a little weird at the present time, but all of these justifications you may have gone through in your Algebra 1 class, so we will definitely cover this a lot in detail. Problem for you. Here's example 1. Now this math problem is going to be a little bit more difficult because you're not going to get an answer that's like a number. So when I say solve for t, that basically means to get t alone. And we're going to be writing a proof. Well, what's a proof? A proof is justifying each of your steps to show your logical thinking. So if you want to try the first step and pause the video, feel free. What would you do in this problem here? And don't forget to write down example number 1. The first one was warm-up number 1. Okay, I hope you distributed. So I'm going to go with d equals 2 times 20 is 40t. And 2 times 5, don't forget to multiply that 2 by your second number. That's an often forgotten step. And then we're going to be justifying this. So sometimes with the justification, we're going to do something called a 2-column proof. So I'm going to put my work on the left, and I'm going to put my justifications on the right. So the first thing I did is distribute, so I'm going to call this the distributive property. Okay? Next step. I need to get t alone. So what am I going to do to this 10 to swing it over to the other side? I'm going to subtract 10. But here's where it becomes a little bit more difficult than the last problem, because you had a number over here, so you might have had 5 minus 10. But in this case, you have d minus 10. Well, what the heck is d minus 10? I have no idea, because I don't know what d is. So I leave it as d minus 10. The 10s cancel here, and I get 40t. Now I'm going to need to justify each line on my lined paper. So what did I do? I subtracted 10 from both sides, so I call that the subtraction property of equality. And I did some math here, so that math is substitution property. Now, subtraction, substitution kind of sound the same, so if you do abbreviate them, make sure you have like the clear R to kind of delineate between them. Then what would you do next? If you want to get t alone, t has a 40 with it, and it's a multiplication, so how do you get rid of multiplication? You divide, and the 40s cancel, so you end up with t equals, I can't really do this, so I can't do d minus 10 because I don't know what d is, so I leave it as d minus 10 divided by 40. It's a formula, a new formula. So I did 2 lines, 2 steps, so I need 2 justifications. Division by 40 is the division property of equality. And then I wrote this as one simplified thing. And I didn't really do any math, but you always need a justification for a step. So writing it divided by 40 is like dividing by 40, so that is the substitution method. And if you're looking at the pattern here, the pattern is, every other line is often substitution because you're doing math. So that doesn't happen with the proofs that we're going to get to that are a little bit more complicated, but that's how you do all these proofs. Don't forget to have everything written down clearly. Thanks for listening. Have a good day.